Hello. By now I would expect that you have in front of you your test and some notes. Some of you did very well on this test and some of you did not. And so we're going to go through the 3 skills that I think we need to improve on for the test tomorrow. Just a reminder, there'll be all skills of Chapter 12 and all skills of Chapter 8. That's a total of 7 skills. Some of them are third attempts, so you may not have to take all of them, but most of you will. You need to know what you're doing and you need to be able to do it quickly. I've made a little guide as to what you should do for each of these skills. So I'm going to pause it here, pause it please, and take some notes. All right, let's go through these. 8b. 8b, you're just multiplying rational expressions. So all you need to do is factor, and then you need to cancel factors. Now there is one catch. If there is division, flip it to multiplication. All right, so keep that in mind. If there's ever division, you have to multiply by the reciprocal. 8c, find the least common denominator. Of course, you want to factor it first. That will help you if it's factorable. All right, and find the least common denominator. Multiply top and bottom by something. Okay, by something to make denominators the same. Typically, the 2 fractions you are adding together, you will not be multiplying the same thing. If you did, if you had to multiply the same thing, they were already the same. And so you don't need to be changing them. All right, so you're gonna multiply each one differently, separately. Okay. 8D. This is the hardest skill because now I'm asking you to put some of the different strategies together. Factor, as always. If it's factorable, factor it. That will help you in finding the least common denominator. That's why we factor. And then you are going to multiply every term, and hence since it's a fraction, it's just going to be multiplied to the numerator. Multiply every term by the LCD. And the reason we do that is because the fractions should disappear. There are no more fractions, and all of a sudden it's just a maybe quadratic or at best a linear equation that you can solve. And then 8a, you need to study your notes or go to 8.2 and figure it out. It's not going to change. It's the same every single time. And we'll go through this skill. All right, let's start with 8c. Add and subtract rational expressions. We cannot add these two right now. Just like if they were 1/3 plus 1/12, we could not add them. We need to make the denominators the same. And so rather than just multiply this side top and bottom by 3 and this side top and bottom by 12 to make the biggest denominator possible, we're going to look at what are the pieces. 12 already has a 3 inside of it, and so you do not need to put another 3 in. It's there. You just need to get the missing 4 over here. Okay, we need to go with that same approach over on this side. The least common denominator, I see a 15 and I see a 5. Well, there is a 5 in the 15, and so I don't need another 5. I see an x squared. Here's an x. Well, there's an x inside of x squared, so x squared is the biggest thing that I'll need. And then x plus 1 is here. Least common denominator. All right, this is what I need each denominator to look like. So what am I missing in this first fraction? I need an x plus 1. So I'm going to multiply top and bottom. Actually, I'm only multiplying by 1, but it's a special looking one. Over on this side, what am I missing? Well, I've got 5. I need to get up to 15. That means there's a 3. And I've only got an x. I need to get up to x squared, so I need 3x. I'm going to distribute this numerator. So it's 4x plus 4 over my LCD right now. And then it's 3x over my LCB. And you can do this to save some time for right now, but in the end we will simplify it back. So I've got a 4x plus 3x, that's 7x. That's just a 4 by itself, so it's plus 4 over. Now I'm going to write my least common denominator. And there you have it. Please don't multiply this out. It doesn't help. Keep it in factored form. Just keep it like this. This is how quick it needs to be tomorrow. Okay, find the least common denominator, multiply top and bottom. This is going to be the difficult one. Okay, first step here, factor. Well, I'm going to notice that this is an x plus 5 and an x minus 5. All right, and that also actually happens to be my least common denominator. I've got an x plus 5 over on this side. I've got an x minus 5 on this side, so I need both of those things, and they just happen to be inside both. Both of them are inside this binomial here. So my least common denominator is x plus 5 times x minus 5. So now, what do I want to do? Well, I multiply everything by that least common denominator. So I'll put a giant parenthesis around this and this, and I will distribute, since it's just over 1. You're just multiplying this to the numerators. So now we will have 7x, 7x, and then I'm just going to pull this because I don't want to keep writing it, all over x plus 5. And then it's plus 5 times the least common denominator. So you're just distributing this out, and if you just write it out, it does take a little bit more time, but you can begin to see what's going to happen here. I'm going to put this in parentheses, 5x plus 67, and then that least common denominator. But what's to remember about this one now is that our least common denominator, is actually in the denominator, so everything's going to cancel here. So you get out your crossing out pen and you cross things out. Whatever is on top and on bottom, that's on top and on bottom. So what do we have left here? Well, I have to distribute this, so we've got a 7x squared, and then 7 times negative 5 is negative 35x. Here I just distribute the 5, so it's plus 5x, and then plus 25 equals, over on this side it's just the 5x plus 67. We've got 5x on both sides, so you can cancel those out. I'm going to subtract the 67. And you have a quadratic with the 7 in front. We're going to try our best to get rid of that. 25 minus 67 is negative 42. 7, 35, and 42 are all divisible by 7, so I can divide both sides by 7. And it just becomes x squared minus 5x minus 6. What multiplies to negative 6 adds to negative 5. It's x minus 6, x plus 1, and thus 6 and negative 1 are your solutions. And you got to check those. Look back at your original equation back up here, and just take a look and say, all right, does this work? And you may have to use your graphing calculator, or you may have to, plug some things in. But what you want to check for most of the time, what the problem is going to be is if you plug this into the denominator and you get a 0. So if I take 6, okay, I'm not going to get a 0 here, no 0 here, no 0 here. Okay, numerator 0 is fine. Denominator 0 bad. So that is skill 8D, solving. Okay, you are not done solving until you give me x equals something. and x equals something else. Or it could be 1, could be 2, could be none. Okay? But it should be all the way to the end like this. All right. And then the last one, graphing rational functions. I'm not so concerned about the graph. What I am concerned about are the answers. And so your graph could be pretty good or it can be pretty bad, as long as you accurately know and understand what a vertical asymptote is. Okay, where is a vertical asymptote going to happen? It's going to happen where the denominator gets close or is 0. Okay, because what happens is that as you put in a number, let's say, well, we can't put in 3, let's put in 2.9999999. Okay, well, 2.99 is going to get really close to 9. So as you get closer, as x goes to 3, this denominator is going to become very small. All right, and 7 isn't going to change. And the closer you get to 3, the smaller that denominator is going to get. And when you take 7 and you divide it by a very, 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 very small number, you will get a very big number. And that is why an asymptote shoots up or it shoots down. It looks like it's heading towards infinity or negative infinity because that number in the denominator is getting so small while the number in the top isn't changing. So vertical asymptote always will be, when does the denominator equal 0? And in this situation, it's when x equals plus or minus 3. And yes, I want x equals. There are two equations, when x is positive 3 and when x is negative 3. And I'm going to put dashes on my graph right here so I know where those vertical asymptotes are. The next question feeds right into it. Please stop using parentheses or set notation. This is how I want you to write it. All real numbers except when x equals 3 or x equals negative 3. Please just do that. I'm not going to explain anymore. Just write it like that. All real numbers except, when does the denominator use it? These two questions are exactly the same. Horizontal asymptote. This is the special cases and you need to study this. In this situation, the denominator has the power. So when x is a billion, you're going to have a billion squared, and that's going to be a super, super big number. Okay, what we're talking about here is what happens as x goes to infinity. Okay, you remember doing this with polynomials. Is it going to go to positive infinity or negative infinity? Well, rationals have other things that can happen. For example, in this situation, when x goes to infinity, you're going to put in positive a billion. Okay, that's a billion squared. That's super big. Minus 9 is not going to matter. So it's 7 divided by a super big number. That's practically 0. All right, and if you go negative, it's practically 0 again. So where is your horizontal asymptote? It's y equals 0. Okay. Horizontal is y, vertical is x. Figure that out, please. Y equals 0. There's your horizontal asymptote. Okay. The other thing to remember is, what if they're the same? Okay, what if that tug of war, the denominator or the numerator doesn't win? Well, then you have to look at the coefficients. Okay, so if there was just, say, for example, y equals 15 x to the 7th over 5x to the 7th. Okay, x to the 7th, x to the 7th, neither one of those is going to win over the other one. And so they really don't matter. It's 15 over 5. The horizontal asymptote would be at 3. 15 divided by 5. All right, finish it up here. X-intercept, when is the top going to be equal to 0? Just set it equal to 0. 7 equals 0 when? Never. No, that doesn't exist. No x-intercept. Okay? And then plugging in 0 for x. This is so easy. I'm sick of seeing people get this wrong. It's 7 over 9. Just plug in 0. Right? Negative 7 over 9. And so the graph is going to look something like this, but I'm not super worried about it. And you have a graphing calculator, so you should be able to do this without